One mechanic said, "If you hear grinding, start praying." The Detroit 6V53 wasn't just an engine, it was a battlefield, with misaligned gears, leaking injectors, and cooling failures pushing mechanics to their breaking points. Why did this compact power plant demand such mechanical precision? And how did it leave its mark despite countless horror stories? Let's dive into why even the most seasoned professionals dreaded working on it. Before we move on, I would like you to subscribe to the channel and like the video. Why did an engine that promised power and efficiency become a source of dread for mechanics? To understand that, you need to start with what made the Detroit 6V53 so different: its two-stroke design. Unlike the more common four-stroke engines, where each cycle involves suction, compression, power, and exhaust over 4 strokes of the piston, the 6V53 did all of this in just 2. This meant every piston fired with every revolution, a design intended to maximize power and efficiency while keeping the engine compact and versatile. On paper, it looked like a mechanical marvel, particularly for heavy-duty applications like trucks, loaders, and even military vehicles. But once it was out in the field, that story started to unravel. The two-stroke system fundamentally altered how the engine operated. It relied heavily on precise synchronization and constant lubrication to handle the increased workload. Every revolution of the crankshaft meant double the action compared to a four-stroke, creating relentless wear and tear on internal components. Pistons, rings, and cylinder liners bore the brunt of this constant punishment. Think of a sprinter forced to maintain pace in a marathon. Impressive for a while, but any misstep would have catastrophic consequences. And with the 6V53, even the smallest oversight could result in engine lockups or catastrophic failures that brought work to a grinding halt. Mechanics quickly discovered that this wasn't an engine you could rush through. Tolerances were so tight that even minor errors during assembly could throw everything out of balance. For instance, aligning the cylinder heads had to be done with borderline surgical precision. A single misplaced gasket or incorrectly tightened bolt could compromise the entire combustion process, sending mechanics right back to square one. Imagine working on something where even the air gaps needed to be perfect, and knowing that one slip-up meant hours of backtracking. The engine's compact V-shaped layout, designed to save space, made it even worse. Accessing internal components usually meant removing several other parts first, turning a relatively simple repair job into a tedious, time-consuming process. And the problems weren't just during repairs. The 6V53's increased firing frequency, once per revolution per cylinder, pushed components to the edge. Compared to a four-stroke engine that only fired every other revolution, this engine effectively doubled the workload on items like bearings and seals. This led to faster wear and, as mechanics described it, a ticking clock counting down to the next inevitable failure. Trying to maintain the engine was like chasing after something constantly breaking down because it was working too hard for too long. The margin for error, almost non-existent. Here's the part that frustrated people the most. Some of these failures didn't just ruin a couple of hours. They could sideline entire projects. The Detroit 6V53 was often used in construction equipment and military vehicles, where downtime meant more than just inconvenience. If a bulldozer broke down in the middle of grading a road, or an armored personnel carrier needed repairs in the field, the ripple effects were immediate. Suddenly, production schedules were delayed, costs ballooned, and everyone up the chain of command felt the heat. Whether you were a mechanic working in a crowded shop or in the harsh conditions of a job site, getting this engine running again was never going to be quick or easy. And let's not forget the sheer physical challenge of working on it. When something went wrong, mechanics often found themselves dismantling large sections of the engine just to access the failing part. It wasn't unusual for an oil leak or a misaligned injector to require hours of disassembly before the repairs could even start. By the time the issue was fixed, exhaustion wasn't just a possibility, it was guaranteed. One mechanic famously referred to the engine as a puzzle someone scrambled just to see you suffer. Painful? Maybe. Accurate? Definitely. All this made the 6V53 less of an ally and more of an adversary for less experienced hands. Sure, it shined on paper with its power-to-weight ratio and impressive torque, but in practice it was almost a liability in the wrong garage. Mechanics needed to approach it with care and precision. Without that, it was almost guaranteed they'd find themselves buried waist-deep in a never-ending cycle of troubleshooting and repairs. What's more, the 6V53 seemed to demand far more than the tools every mechanic had at their disposal. Factory-certified mechanics who had the right equipment might have stood a fighting chance, but smaller shops and field operators found themselves improvising. And as we'll see next, even when they did everything right, the lack of specialized tools could create nightmares all its own. When tools failed, mechanics turned to improvisation, but at what cost? Working on the Detroit 6-valve 53 was an exercise in frustration for those without access to proper equipment, and that was most mechanics in smaller, independent shops. The tools specifically designed to service the 6V53 weren't widely available, meaning repairs often required a mix of resourcefulness and sheer stubbornness. Picture a mechanic staring down at an engine, knowing they lack the exact pullers or alignment tools needed to properly do the job. Their choices? Fabricate something that might work, or put everything on hold while waiting days, or even weeks for the right tools to arrive. It wasn't just tools that complicated things. The engine's scavenging blower and unit injector systems were particular trouble spots. These components demanded absolute precision during repairs, tolerating no shortcuts. The scavenging blower, responsible for forcing air into the cylinders during the intake phase, relied on perfectly aligned gears to function efficiently. If misaligned, it wouldn't take long before mechanics heard the unmistakable grinding of metal on metal, the blower tearing itself apart. And that grinding wasn't just mechanical, it was emotional. The sound meant hours, if not days, were about to be spent removing and replacing this critical part, often in punishing field conditions. Injectors were no easier to deal with. These tiny, high-pressure components had to be shimmed just right to maintain proper timing and fuel delivery. Being even slightly off, that could throw off the entire engine's firing sequence, leading to symptoms that were as frustrating as they were time-consuming to diagnose. Faced with these challenges, improvisation became a survival skill. Mechanics quickly learned to make do with what they had, often coming up with creative, yet risky solutions. Fabricating homemade pullers from scrap metal was a common practice, especially when factory tools weren't an option. Spacers and alignment aids were cobbled together using whatever materials were lying around the shop. These hand-built tools often got the job done, but their limits became evident too. One wrong weld or a weak spot in a fabricated piece could cause it to fail mid-repair, sometimes damaging the very parts mechanics were trying to fix. One mechanic once joked that working on the 6V53 taught him a whole new dictionary of curse words, and it's easy to imagine why. Imagine putting hours of effort into fabricating a tool only to have it snap under pressure. That frustration wasn't just felt on the garage floor, it rippled through projects and sometimes caused major delays. Interestingly, despite all this frustration, the struggles of working on the 6V53 brought mechanics together like few other engines ever did. Stories about the engine's quirks passed down through generations of mechanics, like wisdom carved out of shared pain. Tips and tricks were exchanged in garages and job sites, and there was an almost unspoken camaraderie that came with troubleshooting its relentless issues. For mechanics who successfully conquered its challenges, there was a sense of pride, like passing some unofficial rite of passage. They shared tales of sweat, stubbornness, and ingenuity, forming a community that thrived on resilience. As much as they cursed the 6V53, it was impossible to ignore the respect they gained from taming it. Ironically, for an engine that caused so many headaches, the 6V53 left behind a kind of legacy, because for all its flaws, and there were plenty, it forced everyone who worked on it to develop their skills, work together, and find unexpected solutions in the face of adversity. And as maddening as it was to handle, the engine's quirks gave it a character that mechanics talked about long after its time had passed. But maybe that's the surprising thing. Despite everything, the 6V53 somehow won their respect. The Detroit 6V53 might have been a nightmare for mechanics, but it earned its place as a workhorse. Despite the headaches, its raw power and reliability under extreme conditions demanded respect. It wasn't just an engine, it was a challenge, pushing those who worked on it to find creative solutions and refine their craft. Modern engines may be simpler, but machines like the 6V53 teach something irreplaceable. They remind us how grit and ingenuity can shine under pressure. What do we lose when convenience replaces complexity? Maybe, just maybe, engines like this are what keep the soul of machinery alive.